Every statistic book has a chapter like Chapter 3, Description of Data. And I'm just going to talk my way through it. It's a pretty fast chapter again. And in some courses, this is, we would take this much more seriously. But because the emphasis in this course is different, it's not on crunching a bunch of numbers or collecting data, then to me it's a reasonably minor topic. But I think it's worth walking through this chapter. So let's talk about now. Description of data is presenting data in terms of graphs and tables and other kinds of formats. And so let's see. The author makes a good point here on page 72 in the left-hand column here. A gain in simplicity involves a loss of information. And a good statistician tries to strike a balance in the tension between these two competing concerns. In other words, if you try to simplify the presentation of data too much, then you lose some information. On the other hand, if you try to give too much information, you lose that simplicity, then it's kind of hard to read also. So you look for some kind of balance there. There's an interesting graph on page 74. I like this graph. It's called a chart of imports and exports of England to and from all North America from the year 1770 to 1782. And it's, I don't want to talk too much about it, but it's a very creative graph that allows you to track the imports and import balance over those years. Very, very creative type of graph. It's an old one too. One of my favorite creative graphs, and I don't have it with me at home. I have it at work, and I show it in class, is a graph of the United States. It's a diagram of the map of the United States broken down into counties. So it's about this big, and you see little tiny counties in each state. And it's for the year 2000 election. And the counties that voted for Al Gore in the 2000 election are painted red. The ones that voted for George W. Bush are painted blue. I know there was one county in that election that was a tie, but I'm not sure how they handled that. I haven't figured out where that was, but I know there was one that was a tie. I think it was in Indiana. Anyway, regardless of that, the graph is very startling because I think it's the first time anybody had done this. When you look at this graph, you see that the country is, and I think I got those colors backwards. Al Gore was the blue and George W. Bush was red. When we look at that, the entire country it's almost all red. Voted for George W. Bush, but as you recall, that was an extremely close election. Well, you see parts of the country that have a lot of blue in it, and it's kind of obvious from their placement that those are the big metropolitan areas, like New York City or Los Angeles or Houston or Dallas. So most of the big metropolitan areas voted for Al Gore. The rest of the country pretty much voted for George W. Bush. And so it really says something fascinating about our country, that graph, statistically. So anyway, let's see, page 75. The bottom here, it says a categorical variable is a variable where two observations are either the same or different. The observations cannot be ordered. One observation is not more of something than another observation. All right. Well, I described categorical variables in Chapter 1, in the Chapter 1 video. And it's not something you normally measure with a number. For example, I think I used color of eyes or make of car, or what kind of job do you have. You can't put a number on that. Now you can count. You can count those, how many people have green eyes versus how many people have blue eyes or brown eyes, but you can't put a number on the variable and calculate with that number. That makes it categorical. All right, well, on top of page 76, there are several ways of describing categorical variables. And incidentally, binary variables, which I also mentioned in Chapter 1, remember binary variables have only two possible answers. For example, yes or no, male, female. Those are also categorical. All right, so top of page 76 gives a couple examples of of how that information can be presented in bar graph form. All right, well, he goes through and does some critiques of what are good bar graphs to read and what are not so good bar graphs to read. And I'll let you skim through that. Now, page 80 talks about metric variables. A metric variable is a variable on which we can determine whether one observation is different from another. We can also determine if one observation is more or less of something than another observation, and how much more or less one is from another. So, from chapter 1, metric variable is one that is a variable that can be measured with a number, usually from a continuous range. And so it carries more information. All right, well, he gives an example on page, or the authors give an example on page 80, graphing one metric variable. They went through a newspaper for a week and recorded the ages of people getting married. And as far as the brides, that information is presented on page 81 in several different ways. There's a line plot, a box plot, stem plot, and a histogram. The most important that I know of would be the histogram. A histogram is a bar graph, so that's the bottom graph there is a histogram. It's a bar graph, but what makes it a histogram is that the horizontal scale, those numbers have to be equally spaced. For example, if you had everyone getting married from under age 20, and then you went for people getting married between age 21 and 22, and then people from age 23 to 29, and then people from age 30 to 60, that would not be a histogram, because the scale marks are way off. They're unequal in length. So to qualify as a histogram, then you need to have them equally spaced, as they do on page 81. They have people from 15 to 20, 20 to 25, 25 to 30, and so on. Now, the purpose of a histogram, it delivers a picture of the data that's not skewed or distorted. It's a balanced view of the data, how it's distributed. And you notice the distribution, page 81, is sort of bell-shaped, isn't it? In a sense. In other words, it's in a very rough form. It's peaked in the middle and then tapers off on the edges. So I guess I shouldn't say that's bell-shaped, but it has that characteristic where the center, most of the data is clumped in the middle, and then the ones on either sides are taper off in frequency. All right, but so that ends up being kind of valuable. A histogram tells you what the data looks like, and in some cases it also tells you what kind of statistics should be applied to it. So I'll give you an example of that in a future chapter that I ran into when I taught in Tennessee. How a histogram revealed a mistake in the statistics. All right, so I love some of these graphs in the book. I think the authors do a pretty creative job. Page 87, here they're critiquing what makes a good histogram, what makes a lousy histogram. And page 87, the first graph, has too many intervals. Matter of fact, they listed every age from age, what would that be, age 19 to age 60, something like that. They listed every single age. They said that's too many intervals. We don't need that much information. That's one extreme. And then the second graph is the other extreme, too few intervals. Well, there's one interval. 37 brides are being married. You know, that's so too few many intervals, it's absolutely worthless. It just says that everybody in there is getting married. So I kind of laugh when I see that bottom graph. That's really an extreme.